Welcome to SWMP Design Topsoil Testing Procedure. You will learn when and how to perform soil testing and salvage topsoil. CDOT has developed a series of short videos to assist the engineer in charge during the design phase for successful revegetation. This video is for stormwater management plan designers, CDOT engineers, and consultants. By the end of this video, you will learn to make revegetation design and topsoil retention decisions. You will learn how to determine when testing is needed. Then plan, collect, and ship topsoil samples using best practices to ensure accurate laboratory results. Salvaging topsoil is important to CDOT because our topsoils are alive and contain valuable microbes and nutrients. This is a seed bank for greater diversity that results in higher vegetation success on your projects. You will also learn to analyze site conditions and soil laboratory results to make a final determination regarding topsoil salvage and amendments. Please have the topsoil testing procedure. Find the procedure on the Landscape Architecture webpage. Requirements are documented in specs.
Basically, this process starts at the beginning of a design of a project, and it's sampling the topsoil. So it's doing a composite sample of the topsoil.
Here's how the decision tree works. Start with a preliminary planning and analysis of the site plan, specifically looking at the limits of disturbance area, the LDA versus limits of construction, the LOC. Start by identifying the preliminary anticipated disturbance area. Keep in mind that the disturbance area is different from the limits of construction, or LOC. The limit of disturbed area, or LDA, is the area of a construction site approximately 5 to 10 feet beyond toe of slope or top of fill due to grading activities and allows access for equipment, basically anywhere that vegetation is stripped or the ground is being disturbed. This may include staging areas, storage, parking, and access roads if they are a temporary disturbance. The landscape in the disturbed area, or LDA, will require restoration or alternative permanent treatment. Some best management practices are pavement, mulch, rock, or landscaping. Both areas are typically fenced or marked in the field in some manner. Next, analyze existing site conditions and topography. Before sampling, you will need to determine the number of revegetation units. This can be tricky. Please refer to the pre-sampling planning section of the Topsoil Testing Procedure document. This is available from the CDOT's Landscape Architecture website for guidance on determining the number of revegetation units. Please follow the topsoil salvage and soil testing decision tree to help you determine if topsoil can be salvaged and if sampling is needed. The first step is to determine if topsoil should be salvaged. Consider the following project site conditions. Does the site accommodate the space required to stockpile the topsoil? Can the topsoil stockpiles be located a minimum of 50 feet away from waters of the state? Is there a small amount of rock, 6 inches or less, present? Are there few, if any, noxious weeds present? If you answered yes to any of these questions, then salvaging topsoil is suggested. If salvaging topsoil on projects is over an acre, topsoil testing is recommended to determine the amount of topsoil amendments necessary for your project. Keep in mind the stockpiles must be managed to preserve properties of the soil that support revegetation, such as microbes and nutrients. This step involves reviewing the site plans and talking with the project team. Then the designer or engineer should identify if wetlands are in the project area, and if so, coordinate with the CDOT region biologist or ecologist on how to manage wetland soils during the construction phase. If yes, prepare the stormwater management plan field investigation at the site. Next, prepare a safety plan for fieldwork. The designer or engineer should apply CDOT's standard safety requirements involving the use of flashing vehicle lights and personal protective equipment, and using best judgment to sample in safe places. Be aware of utilities, but official utility locates are not necessary for soil sampling. Coordination with the project engineer should occur prior to the field investigation. Step 2. Field investigation. Does the existing vegetative cover and topography meet the criteria for salvaging topsoil? Do the visible rocks and fragments meet the criteria for salvaging topsoil? Consider the percentage of undesirable species and noxious weeds. If yes, next, analyze the existing vegetation on the site for desirable plant species and ensure a low percentage of noxious weeds and annual grasses. A rule of thumb is that to salvage on-site topsoil, less than 10% of the vegetative cover, including the litter and duff, should consist of undesirable species. Identify the amount of rocks greater than 6 inches diameter visible on the surface. If there is too much rock, then sampling may not be necessary. If surface coverage is greater than 20% of large rock fragments, make salvaging topsoil prohibitive. The project will require a 207 project special provision based on the CDOT maintenance requirements in the standard. If sampling is appropriate, then excavate 6 assessment pits for each upland unit and verify the topsoil depth for each pit. The following information can be used on a project-by-project basis to inform decision-making about how deep to make each soil pit. CDOT does not have a standard depth because the depth will be determined on a site-specific basis. If you are not able to get an adequate depth of topsoil from the pit, then you would not proceed with the sampling. Verify the topsoil depth for each pit. Next, collect the sample. Identify the supplies required to complete the sampling.
So we're out on a construction site. It's actually a structure replacement project. And we're getting ready to do the soil sampling for the permanent stabilization plan. The tools you're going to need is a shovel or a spade, a utility knife, a putty knife, a marker, enough bags for how many landscape units you have, and then something to mix the composite sample in. So we're going to start with the soil sampling of the upland topsoil as it's defined in our instructions on the landscape architecture website for topsoil sampling. So you dig your soil pits first, and what you want to do at this analysis stage is just try to get a feel for the depth of the topsoil on the site and to make the determination in the field of whether or not you want to salvage topsoil if it's any value. And you want to go down to your area that you believe is the salvageable topsoil. So about right here, so your 6-inch depth. And what I like to do is once I have my slice determined, I take my putty knife and I get rid of the subsoil because we don't want to sample that. We're not using that for the revegetation on this site.
Remove topsoil slice from assessment pits.
Clean this up to get a nice even profile, so it needs to be the same width for the entire 6 inches. So just kind of clean it up with your putty knife. And then this is the important step, is you get rid of this litter and duff, because this doesn't count towards decomposed or valuable organic matter in the soil profile. Oh, that's perfect. That's the end result you're looking for. So you do that. So that's one of the composite samples that you're going to mix together to get a representation sample of the organics, the nutrient cycle of all of the topsoil throughout the site.
Provide the correct information on the sample plastic bag.
And then of course you would use a Sharpie. And for this site, I'm going to label it by the project SAP number, and I'm going to call it the uplands. It's a good practice not to let this get too hot, so put it in the shade. But that right there represents how you dig the soil pits, do the determination of the thickness of the topsoil, and then collect a composite topsoil sample to send off for analysis.
Identify the correct storage procedure for composite sample. Prepare for shipping and ship sample per CDOT references. Refer to the topsoil testing procedure for more details. Be prepared to ship fresh samples. Do the topsoil testing laboratory results favor using amended on-site topsoil? If yes, use Soil Calculator to specify quantity amendment specification. Topsoil Calculation. Using the current roadway design and grading plans, the SWMP designer calculates the area of disturbance shown in red per this example and combines that with the topsoil depth acquired from the field visit. The resulting volume of available topsoil from this task will then be compared to the area to be revegetated as seen in green in this example to determine if the minimum topsoil requirements can be met or if additional soil will need to be imported. A soil amendment calculator is available for use on projects. The purpose of the amendment calculator is to recommend topsoil amendment protocols and pay items during the design phase of a stormwater management plan, along with the associated quantities computed by the calculator, must be reviewed and approved by the permanent stabilization subject matter expert for specific site and project conditions. A tutorial for how to use the calculator is also available on CDOT's Landscape Architecture website. If no is your response at any point of the decision tree, please incorporate standard or project special to import topsoil or a soil amendment. Remember, if you are not going to reuse topsoil, then you would not sample that soil. Video.